MQA Certification UK Ltd, presented. Lean Six Sigma Green Belt Training Day 5.
Yes, it's visible.
Okay, see now here understand this. This is X bar R bar chart for grinding process. We are checking the micro finish of the part, smoothness. Okay. Now what we are doing, this is number of batches we have taken. 1 to 19 batch we have taken here, for example, because the data was too large. So I cut short the data. Time we are recording, we are taking on the same time. So in this case, we are taking once a day. We can have once a shift also every day. The third section is like we have 1, 2, 3, 4, my cursor, 5. We are taking 5 readings, right? So the yellow section here is 5 readings we have taken. We have taken the X bar. What is X bar? Average of my 5 readings taken on first at 12 p.m. Then second day reading, average X bar is this, and we have taken average for all the days X bar. And here what I have done, the green section I have taken X double bar. What is X double bar? I have taken average of 19 days of X bar. Okay. So I get X double bar.
Sorry, what do you say? I didn't get you. Get you. Average of the 19 days. Okay.
Yes, this line, X bar line, the yellow and the green line, you see green one.
Okay.
See, this is X bar, this is X bar, this is X double bar. Now X double bar is average of all the X bar reading. See, we have piece to piece variation and we are having batch to batch, day to day variation also we have to see now. So X double bar is combination of piece to piece variation and batch to batch variation. So this is average of all the X bar. X double bar is average of all the X bar. Now similarly, second here yellow one is like it is R. R is range. What is range? The highest here is 125 and lowest here is 96. So range is 29. So I have taken range for all the 19 days, right? Is R. And here R bar is average of R. So this 19 average I have taken here. So 19 average is 28.53. Okay.
Sorry, sir. Let me come. These range.
Okay.
You said the highest is 125. The lowest is 26. I mean, from which graph was the chart did you see the 26? Because I'm going through it and. Can you place your cursor where there is where you see 26, sir? Please.
Okay. Now you first concentrate on the yellow chart, yellow section. These are all readings. Okay. In the column we have 1 to 5 reading, right?
Yes.
So X bar is average of 1 to 5 readings.
Yes.
R bar is range of all the readings. Range means maximum minus minimum.
Yes.
So first we have calculated the average and range for all the columns. Okay, right?
Yeah.
So this is X bar for all the columns. My cursor is here, right? Now we have got the X bar for X bar. Now we need X double bar. Now X double bar is average for this row. Average for this row. Okay, yes, daily average we go. Huh?
I'm following, sir.
Huh.
Hello, Mr. Suraj.
Yes. Can you see?
I said, yeah.
Wait, I'm opening the chart. Wait, I'm opening the chart. You'll understand it. I'll show you. I have to make it big. Now you can see. Now you can see what I did. I will give it a separate color, otherwise it will be very difficult to. Now you see this row number 12. Are you able to see?
Yes, sir. I've seen it, sir.
What I did from B column, this reading average is 1115. Okay.
Yes.
And range I calculated. Range I calculated. What is range? Minimum minus maximum. Okay. Range I calculated 29, 19 for each for the 5 readings. Right?
For
these readings. See, this yellow section is my reading.
Okay. Yeah, range as per the column B should be the highest minus the lowest, which is lowest here is 96. Am I right, sir?
Highest is 125, low is 96. So what is the average? What is the range? 29.
Okay. I'm okay, sir.
Okay. Now we have calculated the range for each batch. What we have calculated? Range and average for batch reading. What is batch reading? On the first day, 12 p.m. Second batch, 12 p.m. Third batch. So we have calculated individual X bar and R. Remember, X bar and R it is, not R bar. X bar and R. We have calculated for 19 batch. Now here what we are calculating? R bar. Now their R bar is average for all the 19 readings. Right?
Yes, I got you, sir. Thank you.
And this is X bar we calculated. Now here it is X double bar. Now what X double bar is doing? Average for all 19 batches. Okay. And this is X double bar. So this is X bar. Okay. Now we got X double bar and R bar. This is required for our calculation from the table. So we will calculate. See, there are two things I told. Specification limit and control limit, right?
Yes.
Specification limit we get directly from the tolerance, right? The upper tolerance and lower tolerance. So upper tolerance is 120, lower tolerance is 70. But we have to calculate the control limit. Now when you see this table, there is blue line and there is red line, right?
Yes.
This blue line is for the control. What is control here? Even my reading is going beyond 115, right? My part will not be rejected. But what I am doing? I am trying to control it on the lower side. So that if there is any problem, there will not be any rejection, right? So this is the formula. X double bar we got.
Okay, sir. A sub 2 is what? Sorry, I didn't get that.
Pardon?
You know, S double bar plus A2 R bar. The A2, I didn't get you, sir. I don't understand that A2.
X bar is group like reading average of batch average. This is batch average. X bar is
Yeah,
batch
no, no,
average.
no. I understood, sir. The one I'm asking, A2. When you want
A2
to
is
get
the
the,
standard.
is that?
Standard. See here. A2 is a standard table, right? If my sample size
Okay.
is 5, my A2 will be 0.58 and D4 will be 2.11. Okay? This is a
Okay.
standard
Fine.
table.
Okay.
Okay?
I
So I am
get it
getting
now.
X bar, X double bar plus A2 R bar. R bar we have, X double bar we have, A2 is from the table. This is the formula. Like this is the value. X double bar is what? Is the mean. Mean of complete readings, right? We got from the table. We got X double bar minus A2 R bar, we got lower critical limit. Now see here the batch between the range between the red and the blue is the danger range. We will not reject it, but we have to open our eyes that my rejection is going up. My chances of rejecting is going up, right? So I have to control between these lines. Now here it went here, it got rejected, right? My
Yes.
specification is 70. It got 69.3. One part is rejected here. Okay. So this is the thing. Now this is like what we are seeing here, how my readings are from the center line. So how close are my reading from the center line we are seeing here. And in the R chart, what we are seeing, how much of the tolerance I am using. Okay. My tolerance is how much here? Design tolerance 120, 70 to 120, right? So 50. How much is my tolerance? 50. So how much I am using? I am going up to 51 also, right? So I am controlling the width. This is the width of the process. This is the central tendency of the process. How much my reading are towards the center. This will show me whether I'm going down, whether I'm going up. If something is going up continuously, there are rules which we'll see. And when we go for mini tab, it will plot histogram also. Okay. It will plot histogram also, and it will give us the mean, mode, and median. This table is given by histogram, like mini tab. What is kurtosis, what is skewness, range, maximum, minimum, sum, count, everything is given. Hope you understood it.
Yes.
Okay. I think I have shared this chart now. So we have seen the practical chart for X bar R chart. Now this is the formula. Okay. Are you able to see the screen? Are you able to see the screen?
No, enlarge it, sir. Enlarge it.
Okay. Okay. Now we will go back to the presentation. Now this is the formula table. Okay. Range is largest minus minimum. What is total spread? Interquartile range is Q3 minus Q1. Standard deviation for sample, standard deviation for population. In sample, we take only n minus 1. Population, we take n. Sorry. Okay, coefficient of variation we saw. Some variance we saw. Okay. Now, is this chart visible or no? We'll make it big. See, when we analyze this, what we saw? 1 point is more than 3 standard deviation from the mean. So, there is some problem. The readings are going down, reading going up, again down, again trend. So, what is it? There is problem. Readings are going from lower to upper. Reading are going zigzag. What does it indicates? See, here it got below rejection also. So, this is there is a standard method, like we can see there is a problem in the process. Now, what is individual moving range? I told about the ventilator system. Ventilator system you say na, saw na? Ventilator system, what is there? One patient is observed. When there is one sample, we go for XMR chart. It is very simple. See, readings are for one reading for all the patients. One patient reading is there. We calculate this chart. It is going up and down, right? So there we use XMR chart. Now there are two types of tolerances we have. Can anyone tell me what are the types of tolerances? See, there is unilateral tolerance and bilateral tolerance. Can anyone say what is that? See, there is one direction tolerance and two direction tolerance. So what is two direction? One direction is on, like my mean is 10 plus 0.1 is unidirectional. It will start from 10 to 10.1. But if it is 10 plus minus 0.1, it will start from 9.9 to 10.1. My mean will be 10 only, right? But my readings will start from 9.9 to 10.1. So it is called bilateral tolerance. This is the formula. So specific CP is specification limit upper minus lower upon 6. CPU is USL minus mu upon 3 sigma. CP lower is USL minus LSL upon 3 sigma. And CPK is nearer SL minus mu upon 3 sigma. Okay?
Hello, sir. Hello?
Yes?
Please, can you go explain, throw more light on this type of tolerance you just called now?
See, there are unilateral tolerance and bilateral tolerance. Okay? Now, example I can give unilateral tolerance is hardness of a material. Right?
Okay.
So, what is hardness? One direction. Hardness should,
Okay.
maximum hardness should be like 7 BHN, 8 BHN. So, what is that maximum value? So, one direction, like it will be from, I give one more example in measurement is like 10 mm plus 0.1. Okay. So, my reading should start from 10 to 10.1. So, that is
Okay.
unidirectional.
Okay.
See, this tolerance is like I can give example of bearing and shaft. When there is a bearing, right? The bearing ID has to be on the lower side. So it will have 50 mm minus 25 microns, 0.025, right? Because bearing has to be smaller because it is press fit. Shaft has to be larger. So shaft will have 25 plus 50 mm plus 25 micron. So shaft will be on the higher side, ID will be on the lower side, right? So we have this unilateral tolerance, one direction tolerance. And bilateral we see every time 10 plus minus 1, 20 plus minus 1. Either it can go 20 is the mean, it can go from up also, down also, right? Are you able to understand? Now we have seen the SPC chart for, we have seen the SPC chart for variable. Now I think it is lunch time. So many times like we do two types of mistake in SPC. The first mistake is to react to outcomes as if it came from special cause when actually it came from common cause. Like sometimes it is very difficult to define whether it is a special cause or common cause. Then what we do? We start increasing the control. We think that the special controls are required and we do it. Second mistake is like to react the outcome as if it comes from the common cause of variation. And when actually it is from special cause. So we ignore it. Sometimes like readings are going beyond the rejection level. So what happens? We think that it is common cause. We will improve the parameters and control it. But it can be special cause also. Now process capability. Now like process capability defined as the capability of improvement of process to meet the purpose or direct comparison of voice of process and voice of customer. Okay. What is voice of customer and voice of process? Voice of customer is basically drawings and specification provided by the customer. Voice of process is what actually we are seeing on the trend. So there are two parts of capability, measure of variability, compare that variability with the proposed outcome. Okay. So like LSL, SSL. Now you see here the shape of the curve. Now the shape of the curve is width is half of the LSL and USL. So this is excellent. But what is a second table? It is covering the going beyond the specification limit. So the region beyond specification limit is rejection. So here the chances of rejection are more. The process capability is very poor. Okay, it is more less than 1 only. When LSL and USL touches this end of the line, then it is process capability is 1. See here, understand. 1 sigma, 2 sigma, 3 sigma. Okay. Process capability is equal to specification tolerance upon 6 sigma. And okay. So we divide this tolerance into 6 parts. Tolerance into 6 parts. 1, 2, 3, 1, 2, 3. Calculating the process capability. Now when we calculate here, the CP is 1.5. CP alone is not the indicator. Now we see here our spread is less. But what we see here, it is out of specification. The readings are shifted towards outwards. So we are not producing good parts. So CP alone is not effective indicator. That's why we calculate CPK also. Now we calculate CPK also. What is CPK? CPK lower is x bar double bar minus LSL upon 3 sigma or upper specification minus x bar upon 3 sigma. So whichever is minimum, we take it. Now what we see here, this is the tolerance, total tolerance. Now even though it is shift, even though the center is shift, what is the center required here? So 0 to 14, it is center required is 7. But center required is here 7. What we observe? What we are observing? Center is okay 5. So center is actually shifting. The mean here will be 7. The center is shifted, but still the process is okay. Why? Because even though the center is shifted, the specification limit is not crossed. So our process is capable. So here that is why we calculate CP as well as CPK. Hence, from the we have seen in the previous slide that CPK talks about process center, also the spread in terms of 3 sigma either of the process center. So CPU is equal to capability upper limit, CPL is equal to capability lower limit. Now understand from this example, I'll show you. Now this is a vehicle. Now vehicle and the road width. Now the road width is tolerance hour, upper specification, lower specification. And this is 6 sigma. Now if the process capability is 1.33 or 1.67, this condition is achieved. It has 1/1/3 of tolerance here and 1/3 of tolerance on the either side. Like if the bus is running, if the bus center is shifted on the line also, it is within the specification. So we call it 1.33, 1.67. Now here process capability is 1, less than 1 or equal to 1, when less than 1. So the width of the road is less than the width of the bus. So what will happen? The bus will have some, like bus will not be able to run properly. The third one here is tolerance and is equal to the bus. So what happens if the center shift is, bus will go out of the tolerance. So 3 conditions are shown here. The best condition is if CP is 1.67 or above 1.67. For 6 sigma, CP is 2. Now process capability and process performance. Now one is capability done. Capability is long term and process is short term. We saw na when we take standard deviation for the sample. Sample means short term. We take n-1. And if it is long term, we take n. Now process capability, that is a determination of variation that comes from the common causes. It generally represents the best performance of the process itself. So we call it a term process capability and process capability index. Standard deviation here is R bar by D2. Addressed within the subgroup variation. Okay. And the process performance is determined by the variation that comes from both common and special cause. So typical customers are more concerned on the performance, not on the capability. So with standard deviation calculation is as per the formula, we take n-1. Address both within and subgroup variation. So what you interpreted from CPK 2.2 and PPK 1.9 for the same set of data. So we have to calculate and see. Actually, CPK should be more than 2. More than 2 means our process width is our specification tolerance is double of process width. Okay, then we have
Sorry, sir.
1/3.
Excuse me, sir. Hello, sir.
Yes, sir. Yes, yes.
I just want to know you said the process CP is a short term and the PP is a long time. Can you just explain, sir?
See, I'll tell you example. Like I told you, pilot production, right? And regular production. So we calculate capability for pilot production also. Pilot production means we are making 50 parts. We calculate process capability 50 parts also. Mass production means 5,000 pieces per week or per month, we calculate PPK, right? So in that, like the sample size is very limited, but it will give us the average. Understood?
Okay, yes.
So process capability. Now we know CP is equal to tolerance upon 6 sigma. So here like process capability is 0.88, 0.833. So what is that? Less than 1 is poor. Okay. Now see the chart here. The process capability is 2. It means the width of the process is half of the tolerance, 1.5. So 1.5 means 0.25 here and 0.25 here is still remaining. CP is 1 means cut to cut. Our tolerance, our specification and our spread is cut to cut. Okay. The customer requirement is, example I have given, 2 mm plus minus 0.1. This is tolerance. Okay. So mean is 2 and it is 2.1 on the upper specification, 1.9 the lower specification. Okay. Now we can compare the reading of two suppliers. So when the CPE of supplier is 0.62, it means the width is more, right? Width is more. And when it is supplier A, the width is less. Okay.
Hello, sir. Are you there?
Yes. Tell me. Understood now? If it is less than 1, the width of the curve is more. So it is spreading. If it is 1.1, the width of the spread is low. So we can compare that supplier B and supplier A. So supplier A and supplier B, who is more capable? So we do capability study for comparing the two supplier lots also. Now process capability examples. Here it is like 1. I told 1 initial also, 1 is cut to cut. We are using complete tolerance. So it is cut to cut. So our center has to be in the center only. Center shifts, then the rejection will start. Here it is 1.33. 1.33 means here it is 25%, 10 to 15% is remaining here and 10 to 50% is remaining here. Even if our center is shifting, then we have some margin of error here. Like our center can shift up to this width. Best is like 1.67 is universal. Like all the automobile supplier ask for CP 1.67. And for claiming 6 sigma units, CP is equal to 2. Okay. So here written. See why we call it 12 sigma here? Because what happens here? We are dividing tolerance into 6 parts. But the width is almost half. When the width is half, we can divide this into 12 parts, right? We are dividing this into 6, 3 part here, 3 part here. So total is 6 and half is here, 3 is here, 3 is here. So 6 plus 6, 12. Now CP is equal to 1.5. CP is greater than or equal to 1.5. The comparison is given here. Example is given. The mean is given 8.5. Standard deviation is 0.1. So we can compare for each reading.
So then I asked this question before. Let me ask again. What is the difference between CP and CPK?
The CP is the process capability. What we do, what is the formula here? One is process capability, one is process capability index. Okay. Now CP is basically width. Our this tail width. There are two aspects of like process capability. The first aspect is the width of the process. This is CP. Okay. Second aspect is center line. Understand?
Mm.
So CP is the width of the process, CPK is the center line. How far is the center line from the mean? Even our width is small, but the center is shifting, then this will touch here, right? This will touch here. See, if our center is shifting this side, this will touch here. If our center is shifting this side, this will touch here. There will be no rejection because we have more margin, but our process is shifted, right?
Yes.
So process capability is the width, process capability is the central.
Thank you so much.
So we compare two suppliers. Okay. See here. With example, it is given 0.22 mean and this. So mean is here. And this mean is here. Now we have to compare the mean of the process also. So this supplier A is shifted. Now this is relation is same. Okay, K like this. We have seen the relation between CP, CPK and PP, PPK. P stands for performance. When we do performance, we do long term. Long term means we are using for production, which is carried out for months, which is carried out for weeks. If we have full week, full month production, full quarter production, then we use PPK. CPK is when we give sample to the supplier, the pilot lot. Then we do CPK and CPK, CP and CPK, right? So this is for short term limited data. This is for long term data. See here, see the center is shifted. LSL towards the lower side. The readings are always all our readings were the lower side. And here there is lot of scope. So what can we do? We can take action and shift this curve on the center side. Now we have seen for the what we have seen before, we have seen for the variable parameter, measurement parameter, length, width, weight, height. Now we will see for the attribute parameter. I told you like defects. Now this is P chart. Just ad is coming. Okay. So P chart, what we do in P chart? This is, can you see the slide?
Yes.
So this is P chart example. P chart is proportion. What is proportion? Percentage defective. Proportion is percentage defective. Here we have defective samples. Defectives means number of defectives, number of rejected, and lot size. So out of 98, we got 28 reject. So percentage is 0.020. Okay. Actually, it is 20%, but we have taken it 0.2. Okay. So proportion. So 0.17, 0.14, this way the proportion is there. For this, if we want to calculate the percentage defective, then we have to use P chart. Example is like percentage defective bottle in packaging line. Suppose if a packaging line is going on the continuous production and we are observing some defects like leakage, cap out. Okay. So we are calculating the defects. So total defectives are number of parts rejected are 20. So defective here, not defects. So we calculate percent defective. We calculate upper control limit for P, lower control limit for P, and center line for P. How we calculate? We calculate with the formula. Okay. Now what we did first here, we calculate the center line. So how we calculate the center line? We have taken the average, right? Total number of pieces and number of pieces rejected. So we have taken percentage. Okay. So it is coming. Then from that, we are calculating P bar. Okay. And we are calculating upper control limit and lower control limit. So P bar is 3 under root 3 P bar minus 1 minus P bar upon N. This formula is standard formula. So here we will track the graph and see where the readings are going. Why?
Sorry,
When
sir.
we do this?
Hello,
Yes.
sir. What the value of P here? Where am I getting P value?
Percentage chart.
From the values we saw here, where can I pick P?
See, I have given example now. When in a bottling plant, we are getting defects. Defect like leakage, cap defect, other defects. So what we do? Number of defectives we have, 98 parts were produced and 20 parts were rejected. Okay. So when we are producing in batch, work, so what we have, we don't have daily quantity similar, right? We will have uneven quantity and we will have defect rate also different. So percentage defective we will calculate here. Label rejection on printing line. We are doing a printing of labels. So number of label rejected and number of label produced. We have the data. Then we have to use this P chart. Okay.
Okay, sir. No, sorry, I just want to be practical here. The formula for these the upper limit, that's UCL minus P here. In that formula here, you have the P. What value will I substitute in this B? Where can I get it and substitute in this formula and get
See,
this?
you are very clear here. Now you have the table here. First of all, P bar you need. What is P bar? P bar is average of this percentage. See, we have like 18, 19 batch of product 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, 22 batch we have. Okay. So for 22 batch average we have na percentage. So we average this percentage. Okay. And this average is P bar.
Okay.
So this average of all the readings here on the percentage defective divided by number of batches. Okay. So we get P bar. N is number of batches. This is the formula P bar plus.
I don't want to take you time. If you can do me a favor, boarding this thing as you did when we did for the other one, NP. So that I can understand I can see the bars on P's, so that we see how it works. Yeah.
You want this table? You want this Excel file?
Yes, I want to clearly see the
okay, I will download it. I have it.
Okay. Okay, thank you. Thank you, sir.
I will download it and share it after the training. Okay, no issue.
Okay, sir. Thank
I
you.
thought that the table is very clear here. I give example when the percentage bottling plant label line, when we see the data, then we can get this. Then here percentage is there. Now here like number of defectives. Now we are not calculating the percentage, we are calculating the number of defectives. So we use this chart. Now see here the percent the total is increasing here. So the central line is also increasing. Okay. NP chart is for like defective bottles per batch, 7 defective out of 100 inspected daily. Now what we were doing here in the past, in the backside, we are taking direct percentage. But what is here? We are not checking every bottle. What we are checking? Fixed quantity. Whether we manufacture 98, we will check 50 only. Whether we manufacture 100, we will check 50 only. Okay. So our sample size is fixed here. Inspection. So we choose NP charts. Okay. Are you getting it?
Yes, sir.
Here we complete inspected 98, we got 20. But here we did not inspected 98. What we inspected? We inspected only 100 parts. Our margin is 100 or 50, fixed sample size. Example I have given 7 defective out of 100 inspected daily. Like example, I am inspecting 100 part daily. So it will be number of defectives. Now C chart. C chart is basically directly defect. There is no percentage. So number of defects. What it is? Number of defects. Defect count. So we measure number of defect in fixed inspection unit used in multiple defects as per possible. So number of defects in the bottle like scratch, dent, labeling issues, counted together, double counting, etc. Printing defects like ink spots, streaks, registration error, etc. So what we are doing? We are not counting defectives. We are counting defects. Whether we check 100, whether we check 50. Okay. So we are checking delivery. Example, this is courier delivery mistake. A courier delivery is doing 31 mistakes, 44 mistakes, 10 mistakes, 26 mistakes every day. We are counting number of defects, right? There it was defectives. Here it is defects. Now U chart. U chart is defect per unit. Example, I give you example like out of 100 units, 5 defects were produced. I am not telling 5 parts was rejected. I am telling 5 defects were produced. Right? The percentage is 5%. Out of 205, 25%. So for this we use C chart. Sorry, U chart. Okay. Are you getting?
Yes, yes, sir.
See, it is demand of process, it is demand of management, it is demand of quality manager's perspective, which chart, which type of rejection, which way of rejection he want to track, right? And depends on product also. Like my customer is more interested. If I get 5 defects in one product, then customer get irritated. So if my product is so bad that there are chances of multiple defects, then we'll use this chart, U chart and P chart. The formula is standard. You will get it from anywhere. Like if you chart on the Google, it will get all the charts formula. Now, some charts are also used in control, like bar chart. like we will see what is the average rainfall in month. We use pie chart also. Pie chart is basically used in by marketing department, by various section to show the percentage of data, the data to present the data. So these charts are also used. Bar chart is also used to present the data. Pie chart is also used to present the data. Line chart. Bar chart, where we seen this bar chart? We have used in Pareto chart, right? Line chart. Where you use it line chart? We have used line chart in Pareto only. So this line chart will show you where are we going. In SPC we use the line chart. Will show you we are going up, we are going down, where we are going. And spider chart. Spider chart, radar chart or spider chart. We call it spider chart also, radar chart also. It is used to control quality improvements and display the performance matrix of ongoing program. Okay, it will have like rating, like suppose supplier rating is there 1, 2, 3 out of 10, and like supplier performance, supplier quality performance, supplier delivery performance, supplier supplier new product development support, supplier like support, supplier information support. So we can see for each section where we are, right? In this sector, we are saying the product knowledge. We are comparing the rating of the customer executive. So we are comparing the product knowledge, skill set customer executive have. What is his passion of doing that? How polite he is? How does he report to urgency? Okay. How his communication is? How responsive he is? So this will give you complete picture of the rating of an employee, right? So spider chart or radar chart is also used. So is there any topic to clear from my side? If anybody has any doubt on this, anything which you want to see, I'll show you the charts. Let me search the chart. I will show the Excel chart. Give me some time.
Okay, sir. I think you can help us how to use Excel to do this chart, if it's possible. How you can use Excel to show the histogram, line charts, and all these charts. So if you can be possible, how to use Excel to demonstrate those application of these charts in case of we in the manufacturing, we can use it to present our report to management.
Yeah. See, you want to see, you want to know the application of this chart, right?
Yes.
So when I will see, I'll again show you. We'll go one by one, explain the every application. Okay, from the back side. Now, where we use the spider radar chart, where we use radar chart is used for like customer executive. I give an example of customer executive or knowledge of employee. Suppose leave it knowledge of employee. If I want to present the knowledge of employee, skill level of employee. So what is the employee's product knowledge? What is the skill set is having? What is the passion of doing the work? How polite is in his work? How he react to the urgency level? Communication, responsiveness. Now rating here is 1 to 10. So for product knowledge, he is 9. Okay. Product knowledge, he may be 4. And this red line is the target. What is the red line? Target. He should be 9 in all levels. But where is he in? Where is in product knowledge? 4. Skill set, he is on 8. Passion, he is on 7. Politeness, he is on 9. Good. But urgency level, he is on 1. Communication, he is on 5. Responsiveness, he is on 8. So this is the actual rating, and red one is the required rating. Now this can give comparison of employee also. We can have the, suppose if we take the example of a car. So we can have, suppose we are manufacturing a car. So we can give the aesthetic rating. There's the aesthetic rating 1 parameter, speed 1 parameter, safety 1 parameter. Then we can give the like a range of the fuel capacity, fuel average 1 parameter. We can give the comfort level 1 parameter. Aesthetic like ease of driving, ease of sitting. This way we can we can show the comparison.
Hello,
So this is
hello,
one
sir.
example.
Hello, sir. How can I use Excel and get this kind of web? Is it possible with Excel?
How can?
Is it possible to get it from Excel, Microsoft?
Yes, everything
Can
is
I
available.
in
You
Excel?
want to draw this chart in Excel, right?
Yes. And
Yes,
present
you
it.
can draw it.
How will I go about it?
See, Excel, I guess we have the chart option. Just let me check.
Okay.
Excel, we have the chart option. When we open any Excel file,
Okay. Okay.
we can even draw the Pareto chart in Excel, you know?
Yeah, it's possible. Yes.
Yes. What is Pareto chart? Line graph and bar graph, right?
Yes.
So both are available in Excel, right?
Yes, I think so.
Ah.
Okay, I just want to confirm. Okay. Okay, thank you, sir.
You want to learn the chart in Excel? I will search. I have some all option because nowadays we are using Minitab. So everything is
Yes.
available.
Yes, I want to learn if possible, so that I can. If you have it, you can share with me.
Let me, I'm checking it. If I have anything like. Okay.
Hmm?
Can you see chart option?
Yes. Yes.
Click on the chart option. Now you go
Okay.
to chart. Line chart, different line charts are given here. Can you see?
Okay.
Column charts are there, bar charts are there, pie chart is there, right?
Yes.
Scatter chart is there, right?
Yeah.
You're talking about this radar chart, spider chart.
Yes.
See, it is there.
Okay.
So most of the charts are available.
Yeah.
Now here we
Okay.
have to understand how to use it.
Hmm.
You can even customize. I am searching the NP charts and P charts for you.
Okay.
Oh, actually, I'm sharing in the group. Wait. I've shared in the group. It will open. Now you want to see the Excel one, na? So everything is available in Excel. I'll share you one by one. Did you got the chart in Excel?
Yes.
It has all the charts. C chart is there, okay? It is drawn in Excel only. U chart is there. You just put the readings. You just change the date, put the units, defectives. It will automatically calculate everything. Even the formulas are put here. Okay. So like it is like counts and it is like defectives. I can say defectives. And this is count is defects. Okay, defect is also P chart is there. NP chart is there with formula. Chart, everything is ready, right? Then individual moving range chart. I told you na. This is also if you put the readings, you'll get it. Okay. X bar R chart is also here. You can like put your format number. You can put decorate it and use it, right? Now histogram, you told na histogram. Histogram can be automatically plotted here. Histogram is nothing. See what they have done. From 55 to 65, 65 to 75, 75 to 85, they have put the range here first. They have divided data into range. And then they are counting. For 55, how many readings we have? So it is putting the reading, number of readings. Okay. So 95 is more, 25 numbers. 105 is 14 numbers. 115 is 11 and 6 and this all. Okay. So you have this. This is all what required is right. So do you have any other doubts?
Okay, sir. Thank you.
Yeah. So please like read all the topics and prepare well for your exams. All the best for your exams.
Okay, sir. Let me throw you back. You just introduce T-test. You did not explain well on the F-test. or Z?
T test and F test.
Yes.
Yeah, actually in the
Can you?
presentation it is. Let me check. So if I share you one video, will you be able to do it?
Yes. Share it.
Okay, I will share one video link.
Okay. Okay. Thank you.
Because the time, actually it was not in the PPT.
Okay. Okay, sir.
Yeah, I'm sharing it.
Let me.
Don't worry. Immediately I'm sharing it. He will ask for the access. I will give the access. Okay.
Okay. Okay. Thank you. Another where I'm confused, I want you to look into just a small clarification.
Yes.
As a Sigma Green Belt, we have this training now. If you are going for Six Sigma Black Belt, which training again you require? Is there any training you require to go for
Basically
black?
what is there? You have a certain project limitation there. Like you have to qualify a financial project, and which has to be approved by your finance department. And a master black belt has to approve your project. Then only you will get the black belt certification. So I don't remember the value exactly. Like for Indian INR, it was 15 lakh INR something was there. If you do the saving of 15 lakh INR, then you are qualified for black belt. And that should be certified by master black belt, and financially, like your company should give a letter that yes, the saving is done.
Okay, from what you said, you do not need this training, like just like you train for green belt. It doesn't require that. It's just only when you have a project.
It requires training. Training is there. No, you have to see there is after green belt, there first is yellow belt, then green belt. Then after green belt, there is black belt. You have one more training for black belt. It will be in more detail. Then you have master black belt.
Oh.
There is a special training program, and black belt exams are like, I don't know, most of the organizations I think have only a permission till green belt. For black belt, they have to be like certification agencies, big certification agencies. Like everybody cannot give black belt training or like exams. Like ASQ have. Then there are like PricewaterhouseCoopers. Some companies are providing black belt certification and training. I am not aware of MQA, but you can check with MQA also.
Okay.
But first clear the concept of green belt. After 2-3 months or 5 months, then you go for black belt.
Okay.
Okay.
Okay. For now, you don't know whether the MQA have the capacity to offer
Yeah, I am not aware
black
of
belt.
MQAs, MQA. I was not aware of MQAs, whether they provide or not. You can ask the MQA team, they will provide. You can write in the chat box, then they will give you the information.
Okay. That's great. Thank you so much.
So thank you everyone for such a lovely audience, and I will appreciate the feedback from your side. So if anything, see, I am also like my problem here is I am from India, and the English level is different from my English and your English, right? So that was the only constraint which I faced. But rest apart, I feel the audience is very good, responsive, participative, and keep learning. Learning should never stop. All the best for your exams. Be positive. Don't scare, like get scared for the results. Life is long. You can again attempt it, right?
Thank you so much. Thank you.
Thank you.
For my side here, I really appreciate you for patience in going over and over to recap when we have gap of understanding. You treat here, let us to understand before you proceed. That is actually called, you are really a good trainer. I appreciate it. In terms of language, I think I hear you audibly. I understand you audibly. Is good for me. Is although there is a little but it's okay. Yeah.
It's
Okay,
learning for me also.
it's good to is your language understanding is okay. Is okay for me. I understand. Oh, you said, and I believe. I keep my heart positive, as you said. In fact, I appreciate you so much. I appreciate you. You are the best. Thank you, sir.
Thank you so much for your comments, and keep in touch. Life is long. We will meet somewhere someday.
Yes, I agree with you. Yeah, thank you so much.
Thank you. Thank you, everyone. Stay safe. Enjoy the weekend.
Thank you.
Have one beer extra.
Thank you.
Thank you. Bye.
Thank you.